Good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be presenting tonight will be the solution of the cubic equation. Okay, cubic equation meaning the highest power of the variable that is unknown is actually 3. I want to present an alternative solution, and I think it's the basic solution supposed to be without resorting to a complicated derived equation. The problem with using the complicated derived equation is actually it's hard to memorize that derived equation. Okay, let's present the solution of a cubic equation. So the title of the topic for tonight will be cubic equation solution using synthetic division. Okay, to present the solution of a cubic equation using synthetic division, we must have to bring out an example problem so we could visualize the importance of the solution without resorting to a solution using a derived equation. Because for me, I've been an engineer and a professor also for quite some time, and it's hard to bring out a solution by using a derived equation if that derived equation is actually a complicated one. If it's only for a quadratic equation, we could memorize the quadratic equation, with 100% efficiency, but for a cubic equation maybe, I don't know if we could memorize that equation because the derived equation is actually complicated. So let's try to bring out an example problem using, a synthetic division. Or I will try to give you an example problem, the given cubic equation. Okay, the unknown variable here is actually x. So we are given an x cubed plus 2x squared minus 5x minus 6. This is equated to 0 because the problem is asking for the solution of this cubic equation without using a derived equation. Okay, the first step on how to bring out the solution of this one is, this is actually a trial and error method. Okay, assume a certain value of x, for the meantime. You try to substitute that assumed value of x to the given cubic equation, and if the resulting cubic equation will become 0 after the substitution, we could say that that assumed value of x is actually, we could get a factor from that one. So after that, we use synthetic division. That's why I said using synthetic division, right? After placing the assumed value, and if the resulting cubic equation resulted to 0, that assumed value is actually correct. So for the solution of this one, I assume x equal to a negative 1. Okay, I'll try to check my camera. It's fine. First assumption, I assume that the value of x, one of the possible values of x is equal to minus 1. Because this is a cubic equation, like what I said, there will be 3 possible values of x. And my first assumption of this one is just, this is just an intelligent guess. Okay? Because if you don't assume a certain value, it's hard to take for the solution of this one. So assume the first value of x to be equal to negative 1. So if we try to substitute this negative 1 back to the given cubic equation, I place it here, function of open quantity negative 1. The significance of this meaning, if this given function of x, when x assumes the value x equal to negative 1, what will be the value? So we could compute for the value by just substituting the value of x equal to the negative 1 to the given cubic equation. So we'll follow the given cubic equation, negative 1 raised to the third power plus 2, negative 1 quantity square, I'm following this one, minus 5 times the assumed value for the meantime, it is negative 1, minus 6, then try to make some simplification. Negative 1 cube, this should be negative 1. Negative 1 times negative 1 is plus 1. Plus 1 times minus 1 is actually negative 1. So meaning to say negative 1 to the third power is actually negative 1. Okay. Negative 1 square, negative 1 times negative 1 will be a plus 1. So a 2 times a plus 1 will be 2. Okay. And the next operation will be a negative 5 times a negative 1. A negative and a negative, it will become a positive. So that will be plus 5. This is a pure constant minus 6. And if we try to simplify this one, negative 1, negative 6 will be negative 7. Plus 2 plus 5 will be plus 7. And a minus 7 plus 7, this is equal to 0. If the resulting f of negative 1 is actually 0, the assumed first value of x is actually correct. So we are now near the solution of this one. We now already know the first value of x. So I place it here, since f of negative 1 is equal to 0. One of the possible factors will be x plus 1 is a factor. If x is equal to negative 1, x plus 1 should be a factor. So for us to solve the other two, the other multiplicand to be multiplied to this x plus 1, we will now be using synthetic division. And synthetic division, it is something like this. Okay, I will try to move my parts over here. I will set it here. I hope you can see me, guys. So, by using synthetic division, I rewrite the given cubic equation. Okay? One of the possible factors is actually x plus 1. Because one of the roots is negative 1. Okay? One of the possible factors of that cubic equation is actually x plus 1. So, to compute for the resulting quadratic equation, which must be multiplied here for it to become a cubic equation, we use synthetic division. We divide this cubic equation by the factor x plus 1. So, the first possible factor on the quotient will be an x squared. An x squared multiplied by x will be an x cubed. And an x squared multiplied by 1, okay, will still be plus x squared. Okay, we put this sign over here. We perform the operation subtraction, meaning after multiplying this one, we try to perform the operation subtraction. So I place it here an open close quantity negative sign, meaning we will be subtracting this cubic equation from the resulting product. So an x cubed minus, the operation is minus x cubed, it will become 0. Right? And a 2x squared minus x squared. So 2x squared minus x squared, they are common terms. They are both quadratic. And a 2x squared minus x squared will just be simply a plus x squared. Okay? And for the resulting part of the cubic equation, this negative 5x minus 6, we bring it down. So this will become negative 5x minus 6. Okay? And what will be the next quotient maybe? Oh, this is an x square. Okay, so the next quotient will be an x. So it will be x. We will multiply x by x, that will become x squared. And x multiplied by plus 1 will just be simply plus x. This is positive, so this is plus x. We put this bar over here. Then again, we perform the operation subtraction. So this is open and close quantity negative sign, meaning we will subtract this one from the resulting product of x plus 1 times x. So x squared minus x squared, okay, it will be 0. Minus 5x minus x, a minus 5x minus x will be a negative 6x. This is negative, this is minus x, so it will become minus 6x. So this is now minus 6x. Okay? And the resulting term on this, we bring it down. So we bring down minus 6. Right? So what will be the next quotient maybe? It will be minus 6. Minus 6 times x will be negative 6x. Right? And a plus 1 times negative 6 will be a negative 6. We put this bar here. Okay? We put this bar. I'm still on camera. We put this bar, then we perform the operation subtraction. We subtract this one from the resulting product. So negative 6x minus 6x, this will become plus. Right? Because the operation is subtraction, this is negative, so it will become plus. So minus 6x plus 6x, it will be 0. And again, if we subtract this one here, it will be negative 6. This is minus, but this is minus 6. So this will become plus also. Right? So negative 6 plus 6, it will be 0. So after subtracting this one to the resulting product, what comes out is actually 0 plus 0, or it will just be simply 0. The resulting remainder is 0, so it is okay. Okay? So the given cubic equation now, x cubed plus 2x squared minus 5x minus 6, the given cubic equation, can now be factored to the product of x plus 1, because our first factor is x plus 1, and the resulting quadratic equation after this using synthetic division is actually x squared plus x minus 6. It is this one here. Meaning to say, this cubic equation here is the product of this quadratic equation times this linear equation over here. Because a linear and a quadratic, it will become cubic. And using our knowledge of factoring, the possible factors of x squared plus x minus 6, the resulting quotient, is actually the product of x plus 3 times x minus 2. Because if we try to expand this one, it will become x squared. The middle term is actually 3x minus 2x, which is just simply x. And the resulting pure constant term is actually the product of plus 3 and minus 2, and that is actually minus 6. So by using factoring, the resulting quadratic equation x squared plus x minus 6 is now factorable to the linear equations, okay? Linear equation x plus 3 times x minus 2. So the resulting product of quantity x plus 1 times x plus 3 times x minus 2 is actually this given cubic equation. And for us now to compute for the possible factors, we'll just equate each factor to 0 and we could compute for the three possible values of x. It's a cubic equation, it should be 3. So if we try to equate x plus 1 equal to 0, first value of x now will be equal to negative 1 after the transposition. Equating the next factor to 0, x plus 3 equal to 0. Again, after the transposition, x will be equal to negative 3. And equating the third factor, the solved linear factor, x minus 2 equal to 0. Okay, after the transposition, x now will be equal to positive 2. So the three possible values of x, okay, by using synthetic division, is the first value is actually negative 1. The next value will be negative 3. And the third value will be x equal to 2. For the first value, we check this one to be correct already because when we place the value f equal to negative 1 back to the given cubic equation, the resulting right-hand side is actually 0. And I don't want to show you anymore. If we try to substitute negative 3 and plus 2 back to the given cubic equation, what comes out is actually equal to 0. So the three possible values of x using synthetic division is actually x1 equal to negative 1, x2 equal to negative 3, and x of 3, meaning the third value, is actually positive 2. Okay, that's it, guys. So this is the way on how to compute for the possible rules of a cubic equation without resorting to the complicated derived equation for cubic equation. Me, myself, I could not memorize it first-handly. Maybe it will take time before I could memorize, or I might bring out the equation, then follow it to solve for the resulting possible rules. But by using this synthetic division, I don't have to memorize anything here. So like what I said, the topic for tonight is a cubic equation solution using synthetic division. Good evening from Los Angeles. This is Professor David J. De Los Reyes. So for those of you who would like to subscribe to my channel is at youtube.com/@ProfDavidJ.DeLosReyes. If you want to share it, please click share. If you want to subscribe to my channel, just click subscribe. Good evening from Los Angeles. Professor David J. De Los Reyes.